Okay, fifth period, I just realized that I narrated me doing questions 2 through 5 for the last 20 minutes without ever hitting record on the program. Wow. I don't even know what to say at this point. Oh boy, oh boy, oh boy. Well, I'm not going to redo the video. Unreal. Did I go back too many times? I did. Oh my gosh. No. Okay. I guess I'll just talk my way through it, math. I'm so sorry. Wow. I'm bad at this. Okay, well, for number 2, the first thing I did was use change of base on the log base m of n, writing it as log n over log m. I don't like using x's as multiplication, so just use the dot. Log m squared over log n, but you see that exponent, it could be moved to the coefficient portion. It can be moved to the front, so it doesn't have to be an exponent anymore. And at that point, I just cross-multiplied, or cross-canceled, excuse me, because I'm multiplying, I could just cross-cancel. So the log n's canceled, the log m's canceled, boom, baby, 2. Interesting question. Not too bad. Straight up and down, just use change of base, and let's see what cancels. Now this looks a little bonkers, but let me tell you what I did first. First thing I did was I looked at my 2 exponents and I noticed that they had logarithms in them. So I took those 2 logs out and I used change of base. Log of 4 over log of 5. I realized that 4 is a power of 2, so that's 2 squared. Scooted the 2 to the front. 2 log 2 over log 5. I did the same thing with log base 7 of 8. Log 8 over log 7. I see that 8 is 2 to the third. So it's 3 log 2 over log 7. At that point, what I did was I replaced the denominators of these fractions with these. And you didn't see it happen because I forgot to hit record. But I did a sidebar over here reminding you that when you divide by a fraction, you do the whole keep, change, flip deal. And I just pulled, some random numbers out of my butt, like 4 over 1/2 is the same as 4 times the reciprocal of 1/2, 2 over 1. That's what led me to this grand statement down here. Because the 4 was going to stay put, but instead of saying divide by the fraction 2 log 2 over log 5, I got to say, no, it's 4 times log 5 over 2 log 2. And of course, 4 over 2 reduces to 2. Same thing happened with the 3 over log 8 divided by log 7. No, that's 3 times log 7 over 3 log 2. And the 3's canceled. That means they had a common denominator, log of 2. Look how easy it is. Look how good life is. I took that 2, put it back to the power of 5. 5 squared right here is 25. That allowed me to write one fraction, since common denominator, log 25 plus log 7 over log 2. And the thing in the orange circle is a log rule. It says, hey, if you add 2 logs with the same base, you get to multiply their arguments. And 25 times 7 is 175. So I had log 175 over log 2 as my exponent. So I just undid change of base and called it log base 2 of 175. Then the exponential base 2 cancels the log base 2. I did both questions on the board, one after the other, side by side. So let's just focus on A for a moment, if you have the ability to not look to your right. I used change of base. So I wrote log x third over log 4 and log x to the 1/2, because that's what square root means, over log 2. I moved anything that had an exponent to the front, noticing that 4 was actually 2 squared. So I moved a 3 in front of its log x, 2 in front of its log 2, 1/2 in front of its log x, and, well, log 2 is just log 2. And rather than having the fraction 3/2 on the front, I just went ahead and put it on the top. That's the same thing in fractions. So, I did that. That way, the 2 fractions would just be something over log of 2. Both of them were. So that was a common denominator. That allowed me to write them as a single fraction. Not only that, 3/2 log x plus 1/2 log x is 4/2 log x. And 4 over 2 is 2. And you see my little green arrow there? That's me showing you that I'm going to put the 2 back into the exponent position. And that's how I got to that bottom line, log of x squared over log of 2 equals 8. Undo change of base, and you get log base 2 of x squared equals 8. And then I used exponential base 2 to cancel my log base 2's. That left me with x squared equals 256. And then I just took the square root of both sides, 16. Or technically negative 16 as well. But if you come all the way back up to the top, you can't take the square root of a negative number within the real number system. So I just disregarded the negative 16 possibility. It would have been extraneous. Now the next one, I had 3 different bases, a 16, a 64, and a 4. So after I used change of base everywhere, I realized, oh, all 3 of those numbers are actually powers of 4. So I just moved all the exponents to the front. I took this exponent from the 4 squared, so that's what the 16 was. You see I moved the 5 to the front. And 64 is 4 to the third, so I moved that 3 to the front. And then I just left log of 4 alone over there. Then I did the same trick with my fractions that I did right here. I did the same thing. So I took that 5 over 2 that I had going on right here, and I put that whole 5 over 2 over on the top of the fraction. And I did the same thing right here. I treated this as a 1/3. Whoops, I erased some of the 3. I treated this as a 1/3 and put it on top. The reason why I did that was because all 3 fractions now had a log of 4 on the bottom. So I just multiplied everything by log of 4. And that canceled all of the denominators and left me with a statement that was only in common logs. Is this the only way to do the question? No. It's just the way I thought to do it. Then I moved things back into the exponent position. I did, x to the 5/2. I did 125 to the 1/3, which is the same as the cube root. That's how I got this 5 right here. Cube root of 125 is 5. And I also condensed right here. Whenever you have subtraction between 2 logarithms with the same base, it becomes 1 logarithm with a fraction in its argument. That left me with log of x to the 5/2 equals log of 5 over x to the 1/2. And then I just use base 10 because log is base 10. It's the common log. That left me x to the 5/2 equals 5 over x to the 1/2. We don't like fractions, so I multiply both sides by the denominator, x to the 1/2. When you multiply 2 numbers with the same base, you get to add their exponents. And 1/2 plus 5/2 is 6/2, which is 3. X to the 3rd equals 5, so x is the cube root of 5. And then lastly, I had a lot of fun with this one, and you didn't get to hear it because I forgot to hit record. But I started with log base y of 81 because honestly I didn't really know where to go, so I just thought, all right, well, I'll just try to do some stuff. So I used change of base, log 81 over log y. I noticed that 81 was 3 to the 4th power, so I moved that 4 to the front. And this is actually where I ended up coming to a stop for a moment. I was like, I kind of got stuck. So I took my given statement of x equals log base 3 of y squared, and I decided to try to solve for y, that way I could substitute. So I use exponential base 3 on both sides, as you can see, allowing the log base 3 to just go poof, fart in the breeze, it's gone. That left me with y squared, I like my variables on the left, it left me with y squared equals 3 to the x. Instead of taking the square root of both sides, I raised both sides to the 1/2. That's the same thing. So y equals 3 to the 3x over 2. And then my orange arrow there is showing you that I substituted. So that's how I got 4 log 3 over log of 3 to the x over 2. This is an exponent in the argument, so I scooted it to the front, which is how I got the next statement. And look what happens. Log 3 cancels log 3, and then 4 over x over 2, I just use keep, change, flip to get 8 over x. And now I actually did record that homework.